everything else, we do want to get rid of it. So make sure that the buttons are in. If it helps, default with everything in and pull them out as you need them. Okay, now I've got my EQ. I've got my high frequency at the top and my low frequency at the bottom. And then I've got two mid controls in the middle here. I have a high mid doing the higher frequencies and the low mids obviously doing the low. The high and the low are both fixed frequencies. The high frequency is fixed in this case at 12,000 hertz. It's going to vary from desk to desk, but this is fairly common. So this is what 12,000 hertz sounds like if I boost it up. Here we go. It's going to get quite uncomfortable to listen to. If I go too far, it's going to get quite hissy and essy. Let me take that out because I don't want to ruin your eardrums. When the encoder is at 12 o'clock, straight up, there's a notch. That's 0. It means I'm not cutting or boosting in any way, shape or form. To boost, you turn clockwise. To cut, we want to turn anti-clockwise. So I'm turning anti-clockwise now, and you'll notice that all the clarity and the intelligibility has gone from my voice. Let me put that back and I'll say it again just in case you didn't understand what I said. If you take out all the high frequency energy, you lose all the clarity and the intelligibility. I'm going to jump now right to the bottom to the low frequency. Okay, I'm going to pull out my high pass filter just for the moment as an experiment to show you what's really going on. Out it goes. Now, this is what happens when we boost the low frequency. On this desk, it happens to be 80 hertz. So this is what 80 hertz sounds like. And as you can hear, it's getting pretty rumbly and pretty uncomfortable to listen to. I'm going to wind it back again. I didn't even get to the full extent of the travel, but I'm sure you can agree it's actually quite uncomfortable to listen to on the human voice. I said a minute ago, in the human voice, there's nothing below 100 hertz of any consequence. So let's just get rid of it. In fact, I'm going to do that now. There we go. I've taken it all the way anti-clockwise. I've taken 15 decibels worth of low frequency gain out of my EQ, and the mic sounds instantly clean and crisp and clear. I'm also going to put the filter in as well, just to give it that double effect. Hopefully now, my voice should sound really nice and clear, and you can hear everything that I'm saying. If I need a little bit more control and I need to add a little bit more bite to the voice, or maybe I need to remove a little bit of nasal sounds, then I'm going to look to the most powerful section of my EQ, which is the mids, the high mid and the low mid. You'll notice that on this desk, the blue one, the blue encoder, dictates how much or how little of a particular frequency I'm going to cut or boost. The green one is the sweepable frequency. So in the mid ranges, because the mid is so powerful, I have the ability to choose which frequency I want to manipulate. So I'm going to wind this low mid all the way up to the top. Here we go. And I've started down really low. So you shouldn't really be able to hear much of this. It should now be really rumbly and bumbly and really uncomfortable to listen to. I'm going to sweep the frequencies round, and as we keep going round, we're entering into the 70 hertz range. We're going to enter, it's becoming quite uncomfortable now. This is 120 hertz. We're going 250 hertz. We're going up to 500, and at the very top here, we get to 1,000 hertz. For those of you who are commuters, this is the train on platform 4, is leaving in 5 minutes. Let me take that out because it's quite uncomfortable. I'm sure you can hear the power that we've got in the EQ section just in the low mids. If you're really astute, you'll notice that the low mid actually sweeps down right to 35 hertz on this desk, which is lower than our low frequency. So there's a lot of tonal control there. Let's switch now to the high mids and see what they do. The sweepable mid here starts at 500 hertz and it goes up to 15,000 hertz, so actually above our high frequency. Okay, I'm now going to boost the frequency again so you can hear the effects of it. Now we've just heard this. This is 500 hertz and it's quite uncomfortable to listen to. As we travel up, we hit the 1,000 hertz train platform announcer voice. It gets quite nasal as we go on here, And I'm going to keep going, and I'm going to eventually get into 3,000 hertz, 4,000, up to 6,000. And this is really getting quite essy and hissy and nasty and horrible to listen to. Right at the top, this is 15,000 hertz. Now, some of you might not be able to hear this because, unfortunately, as we get older, our hearing decreases and it's the high frequencies that disappear first. Let me put that back. Okay, so my EQ is all at 12 o'clock. Actually, to make it more comfortable as a listening experience, I'm going to wind my low frequency right out. I'm going to make sure that my filter is in, okay? Low frequency down to minimum, high pass filter in. Okay, now we've got a great, clean, clear, crisp voice. 3 top tips for you. 300 hertz down low will get rid of some of the muddiness. 1,000 hertz can be quite good to get rid of some of the nasal sounds, or just to boost the voice to give it a little bit more bite. 3,000 hertz adds extra intelligibility and presence to the voice. We'll look at EQ more later in this DVD, so make sure you plug into that chapter as well. As we travel down now, we're in the auxiliary section. Now, there are 2 types of auxiliary. We have our pre-fade auxiliary and our post-fade auxiliary. Okay, the difference between the two: a pre-fade auxiliary means that the sound travels down the desk and is taken out before the fader position. Okay? A post-fade auxiliary, by contrast, the sound comes out after the fader position. So, if I need to send something to the monitors, to my band, I need it to be on a pre-fade auxiliary, and I can do that by setting the button here to be pre or post as I want. I want it to be pre, so I need the button to be in, which it is. Now auxes 1 to 4 on this desk are all pre-fade, which means it doesn't matter how high or low I have the fader, my auxiliary feed, my monitor feed for the onstage musicians, is not going to be changed by the fader. As I say, in contrast, I've got auxes 5 and 6 set here to be post-fade. So if I pull the fader down, the feed to the auxiliary is also going to reduce in proportion. What might I use a post-fade auxiliary for? Well, if a pre-fade auxiliary is for a monitor on stage for the musicians, a post-fade is really for everything else. Most commonly, it could be effect sends, it could be recording feeds, it could be a feed to an overflow room, perhaps a creche, it could be a feed for your hearing loop. There's a whole number of things that you would use a post-fade auxiliary for. Again, we're going to look at some of these a little bit later on in the DVD. At the very bottom, as I say, we have the fader section. The top bit is the mute button. Some desks don't have a mute, unmute, they have an on and off. For this desk, when the light is lit, it means the fader's muted, i.e. you're going to get no sound. I'm going to mute it now just to prove the point. Let me unmute it because you need to hear me. So I need to make sure it's unmuted. I have my pre-fade listen, my PFL, as we've said, that gives me reference into the meters and into my headphones. I have a little mini LED meter down here just for reference. And then I've got my routing buttons. Now you'll notice that I've got LR, 1, 2, and 3, 4. The routing buttons enable me to route the sound internally within the desk. I can send this particular channel, input number 14, anywhere in the desk that I want. For example, I can send it to groups 1 and 2 by depressing the group 1, 2 button. I can send it to group 3 and 4, or I can send it to the main left-right, the master outputs. Now, you'll notice, as I say, the LR and 3-4 are already depressed on this. That's because I'm sending this mic into groups 3 and 4 for the recording, so that you can hear what I'm doing right now. And I'm using the main left-right feed for a little reference monitor in the room so that I can hear what's going on. The fader, of course, is the bit that everybody's familiar with. You might also call it the slider. How far up the fader goes is going to dictate how loud something's going to be. It sounds really obvious, but it's true. If I take this down, my voice is going to get quieter. If I take this up, my voice is going to get louder. So there we go. That's the input on this desk, this is input 14. It's exactly the same for 1 to 13 and for 17 to 24. It might be that I choose to route my input to a subgroup and then onto my master faders, as I say. If I'm going to do that, obviously I need to make sure that only my groups 1 or 2 or 3 or 4 are routed and not my left-right. It could be, for example, that I only want to route my audio to group 1 alone, in which case I'm going to depress the group 1-2 route, so that's now in, and then I'm going to spin my pan control, because pan is not just to the left speaker and the right speaker in the PA if you have a stereo PA setup. It's also an odd and even on this desk, so I can choose to route the audio to just one side or the other. This is now going only to group 1. Now, this is my group 1 master, so the audio is being routed into this subgroup. If I pull the group down, you should hear less sound, and if I push it up, you should hear more sound. Okay, but I've got to make sure, if I want this subgroup to go to the main PA, I need to route it there. So we have the same routing principle at the top of the subgroup, which happens to be here. I can route group 1 to left-right just by pushing this button. Again, I have the same pan control so that I can send this group to just one side of the PA or the other, assuming we have a stereo PA. Or I can route it to both by panning this into the center. There we go. You should now have me back in both sides of your headphones. Okay, again, we have a little LED meter, and we also have a mute button, so I can mute it. Turn it back on again, you can now hear me. In exactly the same way, we have not a PFL, but an AFL now. This is an after fade listen. We're not very imaginative as sound engineers, so we're just going to give things more functional names than pretty names. I'm going to turn off my input PFL so that now on the meters this is my main mix, my main output. But actually I want it to be my group 1 metering. Depress that. Now I can hear what's being sent to group 1 through my headphones if I've got them plugged in. And also you can see now this is group 1 going in my LED meters. The most common use of a subgroup would give me the ability to group similar instruments together. For example, I could put maybe my drum kits down here. I could route my drum kit into group 1. I could route my bass guitar, electric guitar, acoustic and keyboards into group number 2. I could route my vocals into group number 3. And then maybe I'm going to put my lead microphones, i.e. my preacher, my pastor, maybe my lectern microphones into group 4. Now I've got absolute control over the whole drum level, the whole backline level, or the whole vocal level, depending on what I need. It's a really easy way of deriving greater mixing capability. That's not the only use. You could use groups here as part of a recording if you're using a very complex recording system. There's so many different things. Really, you're going to need to delve into the manual then and find out actually what you can and can't do with your own specific desk. As I say, the most common thing is deriving different groups of instruments that we're then going to send on to our main left, right, and into our PA. Now, I'm not saying that you have to have groups on your mixing desk. I'm just saying that they can be quite a useful tool. It might be that you've got quite a small desk that doesn't have any groups. Well, that's fine. You're not likely going to have the routing. It's going to route itself automatically to the left, right. It might be that you have a digital desk with perhaps DCAs or a really large analog desk with VCAs. These are very similar to subgroups in their function, but you can't do things with a VCA or a DCA that you can do with a subgroup. Now, if this is going way over your head, don't worry, because to be honest, very few people have that. We're just going to focus on our input and how we route it through. This is the important thing that I want you to take away from this. So finally, our sound goes from our subgroups and into our master faders. Of course, exactly the same principle applies as before. I have an AFL button so that I can listen to what's in my left or my right. I also have a fader and, of course, a mute in exactly the same way as we have in every case before. Now, I want to make an important point here. When you set your master faders, you need to leave them at the level you set them. If something's too loud, you should be changing that on your input faders, not your master outputs. It's really bad technique to change the master output levels once you've sound checked and got the sounds coming into the desk as you want them. One of the most common problems that every sound tech's going to have to deal with at some point is when you're not getting any sound out of your system and you need to work through your checklist to troubleshoot the problems. One of the first things I recommend that you do is to go back and refer to the checklist that we spoke about when we were talking about plugging everything together. In that checklist, we referred to the sequence in which the sound travels from the mic right the way through to the speakers at the end of the chain. So that checklist is a great overview for you, but what I'd also like to do is look at some different, what we call metering points within the system. These metering points help us to establish where the problem is. Is it before something or is it after something? The first metering point is on the inputs as the sources come into the desk. We've got both the LEDs that we can refer to, and of course we can use our headphones as a great listening guide to hear whether we've got sound coming in. It's as simple as this. If there's no lights flashing on that input, there's no sound coming in. So clearly the problem is before the desk. Check it's all connected, check that the gain's up properly as well. Maybe the phantom power's not been switched on. All of these things are great helps when you're trying to determine why there's no lights flashing. Okay, so now we've got sound coming into the desk and we can see those LED meters going. The next metering point we have is on our outputs. If we're not getting any lights on our output LED meters, we know that clearly there's a problem with the routing inside the desk. Every input can be routed to different outputs on the desk. These outputs might be the left-right, or they might be groups 1 and 2, or groups 3 and 4. That's exactly what we've got on this desk here. If I want to send my input straight to the main PA, straight to the left-right, then it's as simple as just making sure that the LR button is down on my routing. From there, I should be able to see the output LED meters of my left-right faders flashing away to show that I've got signal passing through. It might be that rather than routing my input straight to the main outputs, I want to go through a group first, in which case I just need to change the routing buttons accordingly. So I'm routing my input into group 1 and 2, for example. Making sure that my group 1 and 2 faders are pushed up, I should now see the LED meters flashing away to show that I've got signal passing through. From there, I'm going to route the groups to the main left-right, and then I'm going to go out to my main PA. In every case, I've got 3 LED metering points: my input, my group, and my output. If there's a problem in any one of these LED metering points, then it's going to help me to find out where my routing challenges are. If there's a problem with the routing and the signal flow within the desk, then I can use these LED metering points on the inputs, the groups, and on the main outputs to determine where the problem is at the core. Of course, it's not just the mixing desk that has a metering point. Many amplifiers have LED meters as well. So if you're struggling to get sound to your amplifier, again, use the LED meters on the amp as a great reference. It might be that you're struggling to get a record feed to your MP3 recorder, in which case, check the LED meters on the MP3 recorder to see whether you've got signal coming in. Again, you can determine by simply whether the LEDs are flashing or not where the problem is. So let's put this in context. I'm not getting any sound out of my PA. I can see from my LED meters on my mixing desk that I'm getting sound in and out again in turn. But when I go to my amplifiers, I'm not seeing any LEDs flashing on the meters there. Clearly, the problem is somewhere between the mixing desk and the amplifier. The first thing I'm going to do then is physically check the cables. Are they seated in the connections properly? Maybe I'm going to unplug and replug just to make sure. And then I'll hopefully be able to resolve my sound problem. So if you've checked all your connections are seated properly, but you're still not getting any sound, it's likely that the cable's going to be broken. Now, if you've got a spare cable, this is the time to try it. If not, then try a connection that you know works. Maybe swap things around in the back of the desk or going into the amplifier, try a different line and try and isolate the point at which the failure has occurred. If I'm honest, for me, it's usually that I've left something muted on the desk. On this desk, it's a little bit quirky. Sometimes the LED meters are still flashing even though the channel's muted. So just check that all the inputs and outputs are unmuted as well. So if I'm happy that my desk is functioning properly and everything's unmuted, then I should check at the stage end. A lot of different musicians have the ability to mute themselves. Let's take an acoustic guitar, for example. A lot of guitarists have a tuner pedal that mutes the output when it's engaged. It's always worth checking with the friendly guitarist just to make sure that that's not been engaged by accident. It might be that your radio mic isn't working properly and the preacher's just flicked the mute switch on the belt pack of the radio mic. Again, worth checking that one. Similarly, many instruments have inbuilt volume controls. It could be that the player has left that volume turned down by accident, so it's worth checking with them to make sure everything's turned up to where it should be.